first practical we do. Now, these are all factors affecting resistance, and the first one is something called resistance versus length of wire. And what we do is we take a piece of wire like that, as a long piece of wire, and we set up the test circuit. Now this test circuit goes like this, and let's put an ammeter in there. Now these arrows just represent where we're connecting the wires. Now these wires which go around here, we assume that these have no resistance at all. We assume that the meters have no resistance. Now in this case, this wire is a special kind of wire, and it's called nichrome wire. Now nichrome wire has more resistance than a regular copper wire. It's just, and it has a certain amount of resistance on purpose, and that's so we can do this experiment where we have to figure out how changing the length of the wire affects the resistance. Now, the easiest way to describe this experiment is to show you the results table that we would draw. And the first thing that we'd put in the results table is we'd have length, because that's the thing you change, and that length we're going to put it in centimeters. Starting at 0, going 10, 20, 30, 40, 50, etc. Normally we go from 0 to 1 meter, and that's in centimeters. Now, we're doing resistance versus length of a wire. So that means that the thing we change is going to be the length, and the thing that we measure in the end is going to be the resistance. So the thing we want to work out is the resistance. But in order to find the resistance in ohms, we need to know a couple of things. Now, from our equation before, we've got resistance from V equals IR. We've got R equals V over I. So we need to do potential difference divided by current. So if I do potential difference in volts, and I do current in amps. Now, the potential difference we're going to get there from that reading. The current we're going to get from this reading here. Current from that reading. Right. And we change the length of the wire here. Start off at 10, or I should say 0, then 10, then 20, then 30. We move these two along, and we end up with some results. Now, when it says resistance versus length, that's exactly how we plot it. So it's a graph. We do resistance versus length. Don't forget that was in centimeters and that was in ohms. Now what you'll find in this is that it's like that. It's a straight line. Now that straight line means that resistance and length are proportional to each other. Now we use the phrase directly proportional. And directly proportional means it's a straight line that goes through the origin. Now very occasionally you might not see this. You might not see it go through the origin. It might go somewhere else. And when we say it might go somewhere else, it might go like that instead. So it might go just a little bit higher. So what that means, looking at it, is that when this length is 0, it means that there's some resistance. So length is 0, it means there's a bit of resistance. Now what happens there is, because in real life, all of these wires actually have some resistance. The circuit has a little bit of resistance. Occasionally you might get this, and that will be called a zero error, because that means that when our length is 0, we're not getting the 0 value that we'd expect for the resistance. Okay, now, just to go back then, and just go back to what it should look like ideally, let's put another line in there. Now there's another line for a different kind of wire. So we said this one was nichrome, and this one, let's say, I don't know, we'll say this is iron or steel. Now which one of those has got the most resistance. Now, if you pick a length of wire, and let's just pick, say, 40 centimeters. If we read what the nichrome is, and then we read across what the iron is, you can see that this one is more resistance, and that's less resistance overall. So as a material, this one, now it turns out I've just picked iron at random, just as a metal, to name a metal. I think in real life, nichrome is actually more resistance than iron. I've just picked it at random. There you go.